Um, so that there's no exercise at the end of this section. What we're going to be doing first is, talking about, now that you've done some building, just some additional building tips. I originally had these in the previous session, but I realized after going through it myself and talking with other people that it's better to kind of teach you exactly what to do, and then once you've had a chance to try it, throw some new information at you. So let's talk about this a little bit to begin with. So one of the things that you will probably come up against is the architecture of the system that you're using. So everything that we've done today, right, when you build on Perlmutter and run on Perlmutter, everything is set up so that it works by default, right? So if you do this and don't put any platform in, if you're whatever system you're on, unless there's some random default setting that is changed for, building for other systems, it will run on that system well. Now, that being said, if you are running on, or if you're building on a different system and then pushing up to a registry and then pulling it onto, some other system, you might have to change the container platform, right? So the Mac M series, these are ARM chips. And so if you build for that, it will build, say, using Podman or Docker on your Mac laptop, or newer Mac laptop at least. By default, they will be ARM64 platform containers. So even though these are in an OCI compliant form, they will not be able to run on Perlmutter. And it's because of the platform that they're built upon, right? So what we can do is we can build for a specific platform, or build for a what's called a multi-arch or multi-architecture container, by putting in multiple platforms. And so all you're going to do is just add the minus platform equal whatever you'd like to do. So this is going to be important, especially if you're doing Shifter and are building on a Mac, or you have access to some ARM machine someplace else, and are trying to have containers go back and forth between the two different locations. Now, I do want to explain briefly that while you're doing the build, right? So a part of build is like downloading stuff and actually untarring files, things like this. But then there's also the compile step. So when you're compiling for the architecture that your system is, right, the native architecture, it's going to compile far faster, like usually a factor of 3 to 4 faster than if you're compiling for some other architecture. So it's slightly faster for me to build with Podman HPC, push to a registry, and then pull back with Singularity on Perlmutter than it is for me to do the exact same steps when I'm doing it and building on my laptop. And that's just because of the architecture difference and how fast the compile steps take. Now, I tend to build a lot of multi-architecture builds just because, I don't know, it's my default setting, and I regularly do this. And because I do some testing on my laptop and some testing on Perlmutter, it makes sense for me. You don't have to do this. And the multi-architecture builds, they will take a little bit longer because you have to compile for both. And the multi-architecture builds are going to be a little bit larger. So just know that going into it. Everything we did today, we didn't have to worry about this because we built on the same system that we're running on. But if you're going to be building on other systems, this is something to be aware of. All right. I talked about this a little bit, but we have the version number that we can iterate through or iterate up. And so every time you make a change within the container file, you can iterate that version number. I do want to point out, so a lot of people will use latest, right? So people will build something and then tag it with latest as well, so that you don't have to know what the latest version is. Ubuntu/latest, and it will get you the latest and greatest. So when you're doing it from Ubuntu, you can probably trust that, but not everybody is keeps that up to date. And so you have to trust the people that are updating things if you want to use this and be successful, if you want to use latest. I try to use version numbers for everything. I will be the first to admit that I don't always, but I just want you to be aware of this. And we do have a couple of problems when containers are named the same things and that the version isn't updated with Podman HPC. And we can avoid this by always iterating up on the numbers and only migrating one thing with a particular name and version number. Like that tag has to be unique. So hopefully you don't have to deal with that. If you do, we have a couple of ways to do this. So Podman HPC, every now and then the containers in the cache can get in a bad state. This is actually all on the documentation page. I've kind of indicated with the color here which things are less detrimental. And when I say detrimental, it will take you less amount of time to like rebuild these containers. If you do just the things in green, the things in orange are a little bit harder to come back from. The things in red, you're probably going to have to rebuild all of your containers. But there are some versioning issues that are out there that just have to do with the way that we store things. We are actively looking into fixing this, but until we do, these are things that you can try in order to get yourself out of a bad state. And if you do have issues with this, feel free to send us a ticket. We have dealt with this for too long, but long enough that we're able to help you pretty well. Okay, so now I have some introductions to the advanced topics. And again, we're not going to go into depth, right? There are places for you to go to get other training. There is documentation that I'll point to, but just to kind of let you know what all is happening to allow you to jump in and start using containers the best way that it's going to be for you. Okay, so everything that we've talked about so far is running a container that I spin up, I do something, and I spin it back down. A lot of containers aren't running that way. So outside of HPC, a lot of containers are what we call persistent containers, things that are always running. Things like databases or workflow managers. And NERSC has a way of doing that. You're going to use something called Spin, and Spin has really been created and has been successfully used for quite a while now to create persistent containers and containers that are used in ways other than what we've done here today. So Spin has excellent documentation. It has a self-guided tour, as well as there are, I think, 3 times, maybe 4 times a year, some interactive training like this. And there's fantastic documentation. You can find all about that on their website. And so if this is the sort of thing that you want to be doing, right, maybe for all of your container workflow or for some of it, I highly recommend looking at what all Spin has, because there are things that we can do with Spin that we would not be able to do with the ways of interacting with containers that I've been talking about here today. One of the other things that people like to do is create custom Jupyter kernels using a container. So really the goal here is that you have a container that you have full control over everything that's in it, right? So you can build whatever, Python, R, Julia that you like, and have that be available when you run Jupyter Hub here at NERSC. So you have to include the IPy kernel. Outside of that, it's kind of up to you with what you want to do to make this custom. You do have to create the kernel spec. We have a couple of different ways to do this that I've listed here. In the interest of not making anyone fall asleep, I'm not going to go through that in detail, but just to let you know that it's a little bit of a process, but it's actually really not all that difficult. We do have some good documentation that's available. And then you'll start up Jupyter Hub just like normal. And if you do this correctly, your environment will be one of the things that will be listed as being available. So right now, this works fairly well with Shifter. We do this, I guess I haven't seen anything on Shifter break. We're currently working to make this available with Podman HPC. It is working for some things. And to be honest, I don't think that we quite know all the edge cases that it's failing for right now. So I'm calling it experimental, but I would encourage you to try to do this. And if you do find things that are broken, let us know, because we do want to make this available using Podman HPC for to make Podman HPC as capable as Shifter is. All right, so I don't have individual slides for any of these other things, but we do have some other things that people have been doing that we have documentation for. Running multiple containers within the same job. I think there was a question about that in the chat, so that'd be a great place to get started. We do have the ability to do graphics forwarding. I've done a couple of the XIs type things just to make sure that I know how to do it, but this is not something I have a whole lot of experience with. We do have the Cray programming environment. So if you want to use Cray PE within a container, we have a way to do that right now for Shifter. And we also have some containers that we've built with the Cray PE. So if this is something that you're interested in doing, right, not using the GNU or NVIDIA tool sets, this might be something that would be a good ticket that I could help you out with. We're able to profile applications within containers. This has historically been something that is relatively difficult to do. I think that most centers now are able to do it. You just have to do a few things here and there to make sure that it works well. We do have quite a few people that use VS Code within a container and connect to containers. And then also, running PyTorch, building things with Spack, and then a whole lot of other applications that we've containerized now. We're definitely moving forward where I wouldn't say that we're containers first yet, but we're definitely prioritizing containers as far as building new software and making that available to users. So with that in mind, where do you go from here? So we have documentation, right? I've been giving some individual links here. The links here are just for the top level. There's also a Shifter training that's available that you can watch as a part of our training series. This was done a few years ago. So Shifter has been fairly mature, and so not much has changed since this training happened. However, since then, Podman has become, we're able to do just about everything with Podman HVC that we can with Shifter now. Again, the registries, I highly recommend going through those and understanding what those are, understanding how you should be using those in your workflow, and know what's available to you, both with our registry as well as other places. And, as always, if you have individual questions that, about your individual workflow or things in your field, you can submit help tickets. We also have the NERSC user appointments. So good luck, happy computing. Thanks everybody for sticking around. And if you do have some time, I'd greatly appreciate it if you could fill out the survey.